This conference will now be recorded.
Okay, good morning team. In today's session, we will talk about in this Databricks Data Engineer Master Program. In today's session, we will talk about advanced techniques for writing to the CSV file. So we will be looking at today how we can able to write the data to the CSV file. Okay, so we will learn write data frame to CSV file and write data frame to CSV mode options. So when we are writing data into the CSV file, you can able to use a different modes. Okay, so the different modes. Anybody have any idea what are those modes?
Append,
Hmm?
overwrite. Append.
Append mode. Yeah. So append and overwrite only you have seen,
Right.
but there are. So okay, tell me, for example, if you have data in the location, if I am not mentioning any mode and if I try to write the data, what will happen? Are you getting my question? Let's say I have some data in a folder. I am writing the data without mentioning mode, either it is a overwrite or append. What will happen? Have you ever seen that? What will happen? Nobody.
It will
Maybe.
overwrite it.
Yeah,
It will replace the new.
Are you getting my question? My question is, you have a data frame. You have written first time. No problem. If folder structure is not available, it will ready to create a folder structure. Now, what I am asking, first time it has written data successfully. Second time, if I try to write the data without mentioning mode as overwrite or append, anything, enter that mode option itself, I am not going to keep. What will happen? Okay.
It will
So
happen.
you forgot it. It will throw an error. It will throw an error. Error is one of the mode. So we will discuss all such type of modes today. Then CSV format options. Format options, you can use CSV, Parquet, Avro. So maybe you can read CSV, you can write it as any data, any format. Okay. So different formats we have. So we will see the formats that are available. Now, when you are reading the data, you will use a load. But when you are writing the data, you will use a save option to save the data into the target location. So with the save, to that save, what paths you can pass? Will you be able to pass a file name? Will you be able to pass a folder path only? Will you be able to pass a multiple paths? We will see all those things. Then writing data frame to a CSV file options. While writing the data, do you think we need to use info schema comma true team? While writing the data, do you really need info schema sampling ratio? Those two things, do you think we need or we don't require those two?
Also,
So not
is the
required.
database it's
Not
just
required.
folder, not required in general.
Okay, info schema is not required and sampling ratio also we don't require. Okay, good. We don't require because remember CSV won't store the schema information. That's why if you're writing data into the CSV, you really not required to make the columns as a proper data type. That's why we don't care about info schema sampling ratio while writing the data to the CSV file. Writing data frame to a single CSV file. So generally what happens, data can be read it from the multiple files, but if I want to write the data into a single CSV file, how you can able to write it, we will see. Write data frame to a custom CSV file. So it is very important. Like sometimes what happens when you're doing export jobs, when you're doing exporting the job to the Power BI team or some teams, downstream teams, if you are simply writing through the Spark, it will give you part file, part 001, some alphanumeric name it will give, very big name, dot CSV it will give. If you give that, they will confuse what is this file, what is this metadata. That's why we want to remove all the metadata files. We want to keep only proper name. If the table belongs to the sales.csv, if the uh, data belongs to the new orders or new orders.csv, something like that, the proper name you need to give and save it instead of saving it as saving to a single part file. We want to save it to a custom CSV file name. We will see how to do that. Along with that, today we will understand how to write data frame data to a CSV file with a different delimiters, pipe, dollar, double pipe, tab, dollar, pipe, anything you can able to use. So we will see all these things. Okay. So first, to write data frame to a CSV file, the first syntax is very similar to read. We have a two syntaxes here. Using the .csv you can use. Second one is format of CSV and a save. Instead of load here, save, because target, right, you are saving. Source means format of CSV load will come. Sorry, if you are reading, format of CSV dot load will come, but while you are writing, format of CSV save will come. Okay, this is one syntax. But we want to add some options. Okay, add options to write data frame to CSV. So if you want to add options, you can able to use df.write.mode is normal data frame. You are writing, mode is in overwrite. All those things we'll discuss: overwrite, append, ignore, error. So multiple modes we can able to use it. But these two are the important. So if you want to save headers to the target, headers also you want to save it in the target file, we have to say header command true. Along with that, delimiter, if you want to customize the delimiter, you need to give it here. In case if you don't want to customize the delimiter, if you're not giving delimiter, what is the delimiter it is going to consider to?
Default comma.
Very good. So default delimiter is comma. If I am not giving the header comma true, what will happen? Will it take the headers default or it will not take?
No, it won't take. It considered as a row.
Okay, because header default value is false. Okay, write mode everybody understood, right? So df means when you read the data, you will get a data frame. When you read a data, okay, when you read a data from the some location, you will create a data by reading the data frame. So after transforming, you get a result and data frame that I am writing in the different modes. You can overwrite, you can append, and you can save it into the target path. This is one syntax. Second syntax is format of csv dot save. Okay, so along with that, I am explaining you the second option is, along with this you can also add an option header and option delimiter. These two only mainly we will use while writing. Headers true if you want to write headers into the target. So delimiter, whatever delimiter you want to use, you can use it. If you're not mentioning delimiter, default delimiter, it will take it as a comma. Third one is options. Instead of passing option like this, you can pass through the dictionary. So you can just use header comma true delimiter as hash. You can just pass them as a options %. So here also header comma true delimiter pipe you can pass it here. This is a .csv syntax. This is a format of CSV save into the path. And like these options, this can be first, this can be second, anything is fine. Okay.
When we reading the file, already we will mention option header is equal to true, right? When we reading the file,
Yes.
when we are writing the file, why we need to mention option here, header is equal to true?
Because it will simply ignore, because it will think that you don't want headers to be saved into the file. Why means that's how the system is designed. If you really wanted to be saved headers, you have to mention header comma true. If you don't want headers, you can ignore. That is a customized option that you have.
Okay.
Okay, okay, these are the three syntaxes you are aware. Now I am moving on to the next slide. Write modes. So total you have a 4 modes team. Append mode is basically it appends the content of a data frame to the existing data in the target location. So overwrite, what it does, it overwrite the existing data with the new data that you have in the data frame. Okay, you have some new data in the data frame. That data you will be writing into the target. If you're writing into the target in overwrite mode, what happens is it will remove the existing data and it will save only the new data. Ignore means, in case if some data is already available, it will not make any changes. It will simply make it as a successful without any changes. That entire operation, that write statement itself, it will be ignored in case if it found some data in the target. Fourth one is the default case, default behavior. If you are not mentioning mode, this mode option itself, if you are not mentioning, so what happens is, first time it will write the data because there is no data, it writes. But second time onwards, it will find some data. So what you want to do on that data, you want to remove that data and write this new data, or you want to add this new data to the existing data. It will confuse, that's why it will throw error. Error is the default if you're not mentioning the mode. Okay, so this error, when it will come, you can see throw an exception if data already exists. If data is already exist, it will throw error, otherwise error will not occur. So because this error is kind of a error if exist is the mode. Understood, team? These are the modes we have. Next, formats, so while writing, whatever formats you have, same formats while writing also you can able to use. Next, save path. Save path is, remember team, you can only save these things to the folder. You can able to save these things into the folder, team. Everybody's clear, team? Okay, so
Yes.
you can't able to give any folder name, or you can't able to give any file name, team. So why you can't able to give any file name? The reason is, if you give file name, it will consider as a folder and it will write into that file. Writing data into a single file is not at all recommended. So that thing I'll explain to you. Maybe if you get time today, I'll explain to you today. Otherwise tomorrow. Okay. Now, write data frame to the write data frame to the CSV file with the file options header, comma, true, and a delimiter. Shit, I think delimiter is wrong. 1 second, small mistakes are there. So delimiter can be anything that you can able to use. Maybe if you want pipe, you can able to use pipe. If you want, just a minute. Okay, so now we talked about what, team? Now we talked about file options, right? Now we talked about the file options. What are the file options that we generally use, team? Delimiter, comma, delimiter I am using pipe, because if you are not giving any delimiter also, it will be taking it as a comma. So there are two things, header and delimiter. So header, if you set it to true, the first row is used as the column names and it will be written into the target. If you set it to false, that columns are automatically ignored, it will not write the data into the target. So delimiter is by default, it will consider as a comma, team, while writing. If you're not mentioning, if you are mentioning with some pipe or something, it will consider the customized delimiter. Write data frame with the write data frame with the customized delimiter. You can see here I am putting dollar and double pipe. Along with that, you can see here I want to write the data frame to a single CSV file. Single CSV file means, normally how Spark will process the data. For example, if I have 100 records and backend, if I have a 2 executors, each executor is having a 2 cores. Now tell me, if I have 100 records, okay, let's say I have a 2 computers, so each is having a 2 cores. Now tell me how many partitions you will create.
4.
4 is the minimum partitions is recommended to create. Now when you create 4, what happens? So your 100 records will be divided into 25, 25, 25, 25. It will be processed. When you write the data into the target, it will be saved into the 4 files. Why 4 files? Because this core will write the data into its own file. This core will write that result into its own file. This core will write result into its own file. This core will write result into its own file. Now we don't want to write data into these many folders, these many files. What we want to do is, coalesce of one or repartition of one we can do. Tomorrow we will discuss what are these in detail. So coalesce of one or repartition of one, when you do, what happens is we will be combining. Okay, repartition is not recommended, coalesce is recommended. So coalesce will have a less shuffling, that's why. So what we wanted to do is, if you have a 4 partitions, coalesce will add these extra partitions into the existing partition, these 3 extra partitions to the existing partition. This total data will be written into the target. Okay, that is what coalesce does. So repartition, what it does, from 4, okay, it creates a separately new partition. Into the new partition it will add all the 4 and it will write this result into the target. Okay, here you are not moved the data. So one partition data you kept it, the extra partition data you added to the existing in the coalesce. Repartition, it brings all the data and then it is going to write the data. So meaning data is 100% data shuffling is happening here. So that's why repartition is not recommended, but coalesce is recommended. We will discuss in detail, don't worry too much on those things. But you need to use coalesce of one or repartition of one to make from 4 partitions to a single partition, so that the data will be collected at a single partition, and when we write the data into the target, we can write it into the single file. Okay, that's how you can able to use the single file. Coalesce of one or repartition of one ensures all data is written into a single file, but may not be efficient for large data sets. Why we won't recommend? Because let's imagine you have like 500 GB file that is divided into the 50 uh, let's say 50 files. 50 files means 500 GB. If we divide it into the 50 files means how much each file size is, how much time? 50 files, 500 GB data. Each file size how much? 10 GB. 10
1
GB
GB.
team, not 1 GB, 10 GB. 10 into 50 is 500 GB, right? So that's why each file size is
Yes.
10 GB.
Entry.
So 10 GB file, if you want to handle it, 10 GB itself very difficult to handle it. But now you are saying I want to combine everything into a single file, 500 GB into a single file. That is not at all recommended. So that's why it is not a recommended option for the large data sets. But when you are exporting small data, so then it's okay. The CS will be written as a part file inside a folder along with the metadata files. I'll show you those things today. Maybe you might have seen already in the previous sessions, it is writing underscore success underscore metadata underscore started and part file, right? We have written data from data like blob and we
Right.
have seen that.
Yes.
So we can use the dbutil commands to rename part file and remove the metadata files. That is what in the next step we will be doing. So we will be understanding how to, okay, we will be understanding write data frame to a custom CSV file name. So how to do that is, so first team, this is the code that works. You know what I am doing here? So dbutils.fs.ls, which gives the path name size of the file. So I'll take i.path, meaning only paths I'll get it. So I'm collecting all the paths into the list. From the list, I'm checking whether path contains a success, committed or started, then remove it. If it is not committed, started or success, if it is part file, then this file you have to move it. Whatever file you have, that file you have to move it into the trip out.csv. This is how you have to move. Move means what? Move is nothing but we are renaming the file from part file to trip out. So this I'll show you in the hands-on now. Okay. So but this is also one of the very useful. So yeah, now let's go and see how we can able to do this. Now go to Databricks community. So let me create a cluster first. Create the cluster. I forgot to rename the notebook. Write to CSV. Okay, fine. So remember, Tim, see, when you will say particular file is a text file, Tim, can you quickly tell me when you will say particular file is a text file?
With the extension .txt.
Very good. When you will say particular file is a CSV file?
.csv.
.csv.
Very good. When you will say particular file is a Java file, you know,
.java.
.java. Okay, so when you will say particular file is a Python file?
.py.
.py.
Very good. If we have any file with a .py, it is called a Python file. Okay. So within a Python file, what we will have, Tim? Anybody have any idea? In a Python file, we can have a, so maybe you are not aware, let me tell you something. Okay, let me write it here itself. Every Python file can have, okay, classes. Under classes, okay, see, each Python file can have multiple classes. Each class can have multiple functions. Correct?
Correct.
Right.
So each Python file can have a multiple classes. Each class can have a multiple functions. Now, when you will say particular Python file is a module, okay. So here you can see module is nothing but a. If one Python file, let's say one Python file is called a.py, can be reused in the other Python file called b.py. Then we can call a is a module. So what we are doing, a is kind of a configuration file, configuration notebook. Now what we are doing, a notebook functions we are using in the b notebook. How we can access a notebook configurations or functions into the b notebook, team?
Percentile. By calling them.
Percentile run a.py. If you ask, automatically a functions and all will be loaded into the b, and you can able to use the a notebook functions in the b notebook. So then we will be calling a is a module. Okay, but we will discuss in detail in the future sessions. Don't worry too much on these things if you're not clear on this. Okay, so module means that is a module. Now this module, if it is a Databricks, you are importing, like you are reusing them by using percentile run. But when you are developing a plain Python applications and all, so from the existing Python classes, if you want to do, you will be importing like this. What is import? Import means from some other countries, things that we don't have, we will be importing. Similarly, this is a data frame is a one of the module which is available in the Spark. I am importing this data frame module to see what things I have in this module. Generally, you don't need to import for write statements and all. Just to show you the documentation, I am importing and I'm asking the help. So what it does is, it is going to show you what is there in this module. It will show you. Now let's attach this to the cluster. Now let's ask for the help. Okay, team. Are you able to understand this thing?
Yes.
Yes.
Okay, so this is the module. How I am saying it is a module, you can just go up, it will tell you. Help on module PySpark.sql data frame in spark.sql. Okay, so name of the module is this, and this is having a lot of classes. So one of the classes called data frame. So within this data frame, we'll have a different functions, like if you want to write the data into, right? If you want to write the data, right? So you have a write functions and all will be there here. Something I have seen crossed out. Let me say, for example, write. See here, write is the function interface. Write df.write we are using, right? So that is the data frame module. In that data frame module, you have a data frame class. In that data frame class, you have a write function. What this write function does, it is interface for saving the content of the non-streaming batch data into the external storage. Okay, data frame out into the external storage, we are going to save it. Okay, now, so what this write will return is data from writer, it is going to return. So now I want to ask, so if you want specific to the write, you can check. So write is basically, okay, first let me clear this results, I think. So write, what it does in the data frame module, data frame class, you have a write function. I'm asking the write function, hey, write function, what you will do. So it is saying I am a function who can able to save the content to the external storage, and I will return the data frame writer. But using the data frame writer, what you can do is you can save this data into the particular location. So I'm asking, within the data frame module, we have a data frame writer is a separate class we have. So this class is having a save method. Using this save also, you can able to save it. That's why I am asking what is save. So save takes the uh, format. If you want to pass mode partition by path. Path is a string. Only the folder path you need to give. Okay. So that's how you can able to use save. These things you can also look at through the documentation. I already explained to you these things earlier. So now I'm just clearing these results to make the notebook clean. Okay. Now what I'm doing here, team, what I'm doing here. So basically I'm trying to show you. So I'm reading a two files, a file one and file two. Now I'm going to show you. Okay, now I'm going to show you how many records we have for each passenger count, group by passenger count I am asking, right? Now it is going to give us the passenger count for each passenger. Let's say with the passenger 1 how many trips happened, with passenger 2 how many trips happened, with passenger 3 how many trips happened. So I'm showing you first total passenger count, sorry, passenger count, each, like total counts by passenger count, meaning with the one passenger total how many trips. So I want to calculate total trips by passenger count. With one passenger how many trips, with two passenger how many trips and all. First let me show you that, because I don't want to read entire data, because if you read entire data and keep on writing, it takes a lot of time. It takes 2 to 3 minutes. Let's wait. Now you can see team here. So we have a for each passenger count, we have total trips. Okay. Now if you look at all this, out of which 1,25,773 is the average count that we have. So that I want to take. That's why passenger count wherever we have a 6, that I am taking, and I'm going to show you the count. So even if you count it now, you will get the same records, correct? 1,25,773 records only, you'll get it. Let's see. First, let me give you some idea on these things. Okay, team, you can see same number of records you got. Now so what I'm doing is, so for example, team, let me ask you, first let me check your knowledge till now what you gained. Now I'm reading. Okay. Now maybe I'm displaying. Okay, I'm displaying. Now I'm writing. Now tell me, while writing, do you think again it will start reading the data from the source or not? Do you think it will start reading the data again from the source when you write it or not? See, for example, DF I read the DF. Now I displayed
No.
the DF, and DF I am writing. Now I am asking you, do you think
No,
it will read the
No, it
data
won't.
from source
no,
when you apply
No.
display? When you apply
Already
display,
No.
it will read.
data got assigned to DF.
it won't
Yes,
hit the
data is
source code.
assigned. No, hold on. Data is assigned to the DF, correct? Now I am displaying the DF. It is having a data. DF is having a data. Now uh, DF is having a data or not? First thing, tell me.
Yes, having data.
Yes, it has.
Remember, team, the data that you have in the data frame, you have to be very careful, understand the concepts. Okay. So you are reading a data. It is not reading the data. Only one record will be read to get the structure of the data. When you ask for a display of DF, it will read entire data and display. That's it. Now, same DF, I am trying to write it. When you try to write the same DF, now what happens? Write statement is again an action. When you trigger the action, again it will start reading the data once again, everything. So while displaying, it is the action. When action is triggered, the transformation will start executing. Similarly, when I apply one more action, again the transformation will start executing, meaning it is going to read one more time. So now what I wanted to do, to make this read faster, first time when I read, first time I will read from the disk, second time, so first time what happened, display of DF you said. Display of DF means it is reading data from the disk storage account, and it displayed. Now when I read from the storage account, when I display, this time what I will do, I'll keep this result in the memory, so that next time onwards, instead of reading data from the disk, I can able to read data from the memory. Correct? I can read the data from the memory, because whenever you apply action, the transformations will keep executing until you have catched that result somewhere. So So that's why I have stored this result somewhere in the memory. That's why now what happens next time when you apply a write statement, instead of reading from disk, it reads from the memory. If it is reading from memory, which is much more faster compared to the reading data from the disk. That's why what I'm doing, after reading, I'm caching. After caching, I'm displaying. Now you applied a action, it reads data from the disk, it store it in the memory of the compute. So here you have a computes, right? In this cluster, the computers you have, in that computer you have some memory. You can see what is the size of your memory. 15.25 GB memory you have. So in that memory, I am basically saving these results. Now next time when I use df.write, that is action. That action, instead of reading from the disk, it reads from the cache layer. It reads from the cache layer. How you know whether data is cached or not? You can just, okay. So let it finish.
Only one question. In case the cache memory is full, I mean, when it's reading, reading more than that data. Does it stop or does it try to intimate us, okay, this is what the
See,
records
by
out of?
default, yeah,
Mhm.
by default, cache will store data in the memory and disk, meaning how much ever data it stores in the memory, it will keep that data in the memory. Remaining data, it will spill over to the disk.
Okay.
First time it store into the disk, after that it transfer it into the memory.
Not memory. No. See, for example, you have a 100 MB. Your
Hmm.
memory is only 75 MB is free. So 75 MB it will write it into the memory. Remaining 25 MB it will write it into the disk. So while reading 75 MB it reads from memory, 25 MB it reads from the disk. Okay, getting team?
Okay, yeah.
Instead of referring cache, 25 MB it reads from the disk because 75
Yes,
MB is also full.
because see this is
By
very depth
default,
concept. Hold on.
okay.
This is very depth concept. So lot of scenarios you need to understand. So that thing we will have a session in the future. This is just because it takes a lot of time again for me. See, just for display it took 2 minutes. That's why every time when I'm writing it takes 4 or 5 minutes. I can't able to complete the session. That's why I'm just introducing this caching. But we will have a in detail session, cache or persist we have. When you really need to cache it, we will discuss that. Why you are really caching in the disk? It is not required, right? Instead of caching the data in the disk, why cache in the disk? Why can't you read data directly from the storage? So that things are there because you did not know what is the real scenario for caching. So we will come to know. This is just a reading I have done because to make this read statement also faster. But not only read, we will be doing in a multiple other complex scenarios. We will discuss them. But high level, you remember when we use a cache, it is storing data in the memory. How
One
you
more
know it's stored
question.
in the memory? Wait, wait, I'll take wait. Okay, so I think it is not required action. See here, green dot. Are you seeing? So each dot indicates a one kind of a transformation. But remember here, cache indicates this green line. Okay, this cache indicates green one. Remember, yeah. Tell me now.
First time when we write data frame, when we are reading the data, it store it into the DF. When we are writing the data, you said like it will read from the source. Already read the data and store it into the DF, right? So two
What is
times
Spark?
when
What is
I
Spark?
didn't.
Spark is a lazy evaluation or not?
Yes.
Spark is a lazy evaluation team. Spark is a lazy evaluation means whenever you apply action, it reads the data, but it will not hold anything in this data frame. See, if it is a continuous process, it will just reuse that result. Okay. But what happens in the Spark is you have a transformation one, you have a transformation two, you have a transformation three. So when you apply action, then only 1, 2, 3 it is going to execute it. For example, on T3, if you applied some other calculation, okay, for example, here you asked for the sum, okay, so in other calculation you are asking for, let's say, some filter you have done and you are asking for the here sum, right? Here average you asked. Now what it has to do? Now there is other action. Now again what will happen is this T1, it has to push this filter and read the data. Again it has to apply some second transformation, third transformation, and it will get the result. Meaning whenever you apply action, it will look at the transformation order and it execute all the transformation for every action. Now to avoid execution of this transformation, because you are not leaving if I'm not explaining this, that's why let me complete this, because otherwise if you keep on asking it will be very disturbing. Instead of that, let me complete the things. Okay, let's imagine now it's okay, I'll explain it. Okay, now let's say Tim, you are reading a data. Okay, you are joining, you are applying a group by. Okay, now what happens, you are applying after group by, you are applying a sum on the, like let's say df final is the final data frame you have. Okay, so now tell me, this df final is really holding the data or not? Now I have not applied any action, will it hold any data now? Will it hold any data, I'm asking you?
We
No.
are thinking it holds the data. I'm thinking it holds the data. It is reading and joining and group by and store it into the df dot final. When we call the action, it will display the
Data, yes.
What you
No,
understood till
when
now
we
everybody?
call the action, it will process.
This df will not hold any data, team. Till now I struggled a lot to explain all the concept. Lazy
Yeah.
evaluation we went in detail
yeah,
session, you are
understood. I
asking now
understood.
again.
Yeah.
Now this df underscore final will not have any data. Okay, when you apply action, why, like I also explained catalyst optimizer, tungsten optimizer. In catalyst optimizer I have shown you, first one filter I kept, last one more filter I put. What is happening in the back end physical plan I have explained, where it is moving the filters to the front. Why it is able to do all these things is, when you apply count, for example, it look at the transformations that you have, it will see in which order this transformation needs to be executed to get this result. Similarly, this df underscore final display, okay, let's say if you think that way, df underscore final is holding the data. So now if I apply df underscore final dot count, what df underscore final will does now? It is already holding the data. Just is it going to return the number?
No, that's where
No,
the
it is
actual
not
action
going to return
starts.
the number. It is not. So when you ask a count, it is not reading the actual data. It is reading a partitions, like reading a data into the partitions. At the beginning itself, it is just getting the counts. Okay, in this partition 333, and it is just in the df final, it is going to tell you, so these many records we have. Count means it just like calculate and get the count only, but actual data will not processed, because it will try to minimize the amount of data that is transferring to the next transformation, because user is requested only for the count. When you need count, why I have to return the data, actual data? So that's how Spark is optimizing. Now what happens, first time you asked a count, it will give you the only count. Second time when you asked, second time when you asked uh, data, display data, it is going to display the data. For displaying data again, it is, so when you apply display of data, again it is a action, it look at, okay, there are 4 transformation, let me okay, let me just execute in this particular order, in which order I have to execute to get the final data, it is going to think. Let's say, so to make more clear on the subject, let's say 4 transformation with the df underscore final one dot count you have done. Now df underscore final one dot filter, so there is a filter transformation, This is df underscore final 2. Now, if I ask df underscore final 2 dot count. Okay, now let me ask, now tell me team, this is one action I already completed. All the transformations ran and completed. Now tell me, when I apply a second action, df final 2 dot count, do you think it just use the result that is there in this and it will filter on top of the result that is held by this data frame, or this filter will be pushed at the beginning, read statement, and then it reads only required data, apply join group by? How it will happen? Will it push this filter to the front, or this filter will be directly applied on the df underscore final?
Filter is pushed to front. That's what the lazy evaluation is.
Why it is moving to the front? Because it is a lazy, sorry, as per your knowledge, if you think, if this df is holding the data, if this data frame is holding the data, then it should apply filter on this data frame only, right?
No, it won't. It didn't do
No,
the
no, it
action.
won't apply like that.
It won't do that.
Okay.
Until
Now you
you perform
understood
the
at
action.
least.
But it
Yeah,
should
yeah.
push
Data
down.
Yeah, it's
transformations
lazy.
will be re-executed every time when you apply the action. So that's why I don't want to calculate every time. Let's imagine other way. Now you understood that this filter, it is moving to the front and reading all these things. But I realized that reading, joining, group by, these are very costly operations. Now this result I want to put it in the cache, so that now what happened, if you ask df underscore final, spark will look at all the transformation, and it try to understand which transformation it has to order it to get the data. But it realized meanwhile, hey, why I have to recalculate? Really, I already have result in the memory. Somebody already kept the code ready. Let me take the uh, ready-made food or ready-made result and let me display. So it will just take the cache data and it will display. So when you apply on df final filter, now it is not really going to execute this. It reads data from the cache and it applies the filter. That is the beauty of the cache. Cache, what it does, before it execute transformation, first it checks, is there any of this transformation result readily available? If readily available, on top of this result, what are the other transformations that I need to apply? Only those transformation it will optimize it. Understood now?
So Malay, with that, can we safely say that catch is the one which runs before the count is produced? I mean, before the count is given.
Okay, so this is also very good question. Let me tell you, cache, df dot cache, when you say, this cache is again a transformation. So first time
Oh,
if you want to catch the data, you have to read, join, group by, then it can cache it. But in order to trigger these 4 transformation, at least one action you have to fire it. So df underscore final, first time if you fire it, then it reads from the source, join, group by. This time it will be caching in the result, caching this result in the memory. Second action onwards, it will not re-execute all these things. Directly it reads the data from the memory and do the further transformations. Understood?
okay.
First
Thanks.
time, if you execute df.cache, it is not going to cache it until you apply action, because this cache is also one of the transformation. This cache to happen, because you are asking df.cache, but you are not applying any action, means why it has to cache it in the memory? Meantime, somebody else might have used it. You are simply writing the code. As soon as you write the code, and if it is caching the result in the memory, it is waste, right? Because you do really not using at this moment. That's why when you
Right.
apply action, only it is going to cache it. Very depth concept. That's why I said you need to wait. Some things you need to wait him. Otherwise, it takes a lot of time. Only thing is we will be deviating from the concept. That's the problem. But you people are keep on asking same question. That's why I need to deviate. Okay. So understand, sometimes I'll take those sessions when I say later you have to leave such things. Okay. So df.cache, so I stored it in the memory, you have seen. So you can also see this, whether it is really stored in the memory or not. You can just click on the job 7. You can see here in the DAG, you can see it is showing in memory table scan. Okay, understood? Okay. Now Let's say now team, what I will do now, display of df I am doing only display of df. Earlier display of df it took, earlier action it took 2 minutes, but now action how much time it will take? It takes less time than the 2 minutes, because now this time it is reading from the memory. See how quickly it is giving you the result. Within 1 second it is giving the result. Understood?
Yes, Malay.
Understood team? But in case if you are not caching this result in the memory, you have seen already in earlier, right, in earlier lab. So we have seen, we are reading same statement with the different syntaxes. It used to take a same time. So here first time if it took 2 minutes means second time also it used to take 2 minutes. Understood?
Right.
Okay. Now this df is basically pointing to the memory location, because the data is in the memory now. Now what is the first syntax? Df dot write dot mode csv, df dot write mode format of csv save into the target path. So first time, see, always remember one key thing. I always reusing only the df only. I am writing into the multiple locations. Writing is only df. Same df I'll be keep on writing in the multiple locations. Okay, df dot write dot mode is override csv. Down syntax is, after writing this data into this location, I am reading that data again from the output one. Okay, this is different data. Whatever data that you have written into the output one, that data I am reading again to show you same data you have written. Similarly, this is one syntax, df dot mode of override csv. Other syntax I am going to execute is df dot write dot mode of override format of csv save. See, this is format of csv save. This is directly csv of path. Both syntaxes are anything you can able to use. Now tell me, do you think will it write headers now or not? Do you think it will write headers or not into the output one?
No.
No.
It is not going to write the data into the output one folder. Okay. See, writing only it is taking this much time. If the read is also there, try out. So cache, you don't use cache and try to do the same thing in your while practicing. You see, it takes a lot of time. It takes more than 3 minutes for you. Okay, took more than 1 minute to write. Now let's try to read the same data that we have written and see how much. Okay, so it is very faster now. Okay, now you see this data actually, this data is actually we have not cached it, but it is still reading quickly. So the reason why it is reading quickly, so I'll tell you here. If you come here, the transformation that we executed here is one more thing is there. So it is filtering out lot of data and it is taking passenger count is equal to 6. So that is the reason why it took more time. Okay, but here whatever data you have only 1 lakh some 24, but there 26 million records, out of which 1 lakh 24 records it has to filter out. That's why it took more time. But now, so we have done a caching as well. Now what happens is we have written quickly within 1 minute. Now going forward, what happens? So it start reusing that data from the memory. It will be faster while writing. Writing also will be faster. You can see that. So now you see headers. Headers. Where is headers? Okay. See, headers are not written. Okay, we have not mentioned option header comma true. That's why, are you able to see headers here? Are you able to see headers here?
No.
Please respond. No. Okay. Similarly, this is one syntax. Park dot, sorry, df dot write dot mode of CSV. The syntax. Second syntax is same data frame. Mode is override. Format of CSV. Save into the output to different location. Now you see it will be faster. I think it should be faster, because now what happens is that cached result we stored in the memory. Cached result we stored in the memory. So now it will be reusing this particular result. Okay, data frame, same df I am using, so that's why it will be applied, same action, right? Same action, so it will reuse the previous result which we have cached it in the memory, and it will be faster. Now if you try to read it from the output to, so it's just 1,25,000 records, sorry, 25,000 records, it will be faster. But while writing only, so from 26 million records, it is just taking a 1,25,000 records. But first time 1,25,000 records it took and cached it in the memory, and it started reusing the data from the memory from now onwards. Okay, you see here also we don't have any header. Here also we don't have any header. Now come to third one. So now we will be started using the options header. Now you see this is a .csv syntax. This is the format of CSV save into the target location. This I am writing into the output to 3. This is I am writing into the output 4. But same df I am writing into all these locations. Only thing is this time I am using header comma true. Delimiter is pipe. If you are not giving any delimiter, what is the delimiter it is going to take? Comma. So write is complete. Now I am going to read it. So everything is happening through the memory team, but read statement is quicker because it is just reading a 1,25,000 records. Remember, you have to only focus on the write statement. Write statement, why it is faster from 26 million records? Because I am reading a 2 files. Are you getting it? I am forcing. I am putting
You
here a lot
mentioned
of
Yeah.
focus. I am reading a 2 files. After
right.
reading the 2
Passenger
files,
count is
I am
also
caching the result. Okay. After caching the result, I displayed the df. But after display of df also, that result is not cached. Cached means it is cached, but the action is a different type of action. The action is writing to the external storage. So when you apply this action, it is cached it and it is started reusing from next time onwards. So that's why, so here and all you can see it is taking very less time. First time when you apply this kind of action called overwrite in, write into the external storage, count is different. Count is basically what it will take. Count is different, display of df is different, and overwrite is different. So let me tell you first, because you will confuse. One confusion you might have is you already did the action here. Why again? Why again it took this much time when you are overwriting? Why nobody asked this doubt? You clear? Everybody clear? So
Yeah,
in this
already
case,
data is existed. If you again we will it will throw an error. That's why you are mentioning the mode override.
no, no, not. I'm not talking about that. I'm talking about this DF. Why it took this much time? Here, second time onwards, override is taken just 4 seconds, right? But why it took 1 minute here? The reason I'll tell you. When you say display of DF, you remember. I think you did not remember all these things. You need to go through the session stream again and again. So, so 2 jobs are created. Job 7 is basically for the action. Click on view and see how many records it is really scanned. Go to the SQL/data frame. Please put some effort from your end also, team, because if I'm struggling a lot, but if you are not doing the same from your end. So when you said display of DF, right? When you say display of DF, what is going to happen is it is basically taking only 20,000 records only. You can see the output. You are writing only, so you are displaying only 20,000 records. 20,000 records you are displaying means not even 20,000 records, but it is trying to collect only 20,000 records. Out of 20,000 records, it displayed only 9,191 records. So it is saying 9,191 plus rows, but actually it collected out of 1,25,000, it collected only 20,000 records. We have seen, right, how many records it is collected. It collected only the job ID 7. It collected only 20,000. So now if it is collected only 20,000, what is going to happen, team? What is going to happen if it's collected only 20,000? See, in the in memory table scan is 20,000. Why it is like put only 20,000? Okay, why it put only 20,000? The rows output is 63,817. So it is basically not even returning all the records. So first thing you need to understand, when we apply this passenger count equal to 6, so how many records we have? That's why I displayed everything 1,25,773. But as we have used a display, it scanned the file, okay, and it scanned the file, and let's understand. See, it scanned all the records, meaning 14 million records it scanned, but it filtered out with the 63,817 that records it stored in the memory. From the memory we are taking 20,000 records, and those 20,000 records it is trying to display, but due to the display limit, it displayed only approximately 10,000 records, 9,000 and something. But while writing, do you need to write only these many records, or you need to write all 1,25,773?
All record.
All record. That's why when you apply this action, okay, this action is limiting the number of records. That's why what happened when you use the first time write statement, it read all the data again and stored in the memory. That's why second write onwards, it is taking only 4 seconds, 3 seconds, 2 seconds, very less time, because second time onwards it started using from the memory. First time it read the data from the storage, but it is not read all the data. It read only 20,000 records. But second time when you write writing data into the output one folder, when you write it, it has to read everything to write it into the memory. To write it into the output one folder, it has to read everything. So when it read everything, it stored in the memory. Second write onwards, instead of basically reading everything and writing, already the data that we supposed to write it into the target is in the memory. It reads data directly from the memory. So not sure, team, how many of you really understood. So anybody
Malaya,
have
for overwrite option and write option, we no need to explicitly define the cache, right? The second time onwards, it will automatically take.
yes, no need to say. See, it starts looking at the transformation. Before it look at the transformation, first thing it look at, hey, before I execute transformation, is there ready-made results in the memory? It look at, okay, ready-made result is there in the memory, means it ignore transformation, it returns result from the memory.
Okay.
Okay.
Yeah.
So option delimiter. For example, while reading, if I am not giving the delimiter, what will happen? So I have written as a pipe, but while reading, I am not giving that. What is happening now? You can see it is coming with the pipe,
Single
single
column.
column. Okay, so that is what you should understand. While writing, also while reading from the target location, you need to use a proper delimiter so that data will come properly. Okay, now it is coming properly. This is with the options.csv. See, we completed df.write.mode option add the delimiter with the CSV. Next, I'm going to show you df.write.mode options save format of CSV option. Okay. This is our fourth write statement. So it will be very quick because it's from the memory. So spark.read from the output. See, now I have written as a dollar as a delimiter. Now I have to read data also through the dollar only. Okay, so if you read it through the dollar, it will come properly. If you're not using this dollar, it will not come proper. Okay, understood, team? Everybody understood? So it's coming like this. The dollar is the delimiter. Very similar to that, the third option, so it's coming properly now. It is fetching result. It came properly. Okay, this is the output 4. Now I'm moving on to the next scenarios. Is using the dictionary, we can put the key value pairs and we can pass it to the options. So this is the dictionary header comma true, delimiter is hash. I'm passing to the options D1. So this is the output 5. I'm writing into the output 5. But same delimiters I'm using while reading also. You can use the same statement for reading. Correct? Any confusion in this? Only caching only I know some people is having some confusion. Don't worry about it. We have in-depth session. Ignore it if you are not clear on that. Okay. Next. This is the dictionary 2. So I am writing with the CSV. Okay. So this is the dictionary. I am reading with the this one. So this is a CSV way. This is the format of load. This is CSV way I have written. Here I should write it as this way, right? This way I have to say. So I'm overwriting, nothing will happen. It's a overwrite, right? It will overwrite. Now you can execute it. Now you can able to read the data from output. Please be in mute team. I'm seeing some noise. Vinay Kumar, please go mute, please. Okay. Now let's talk about the write modes in the PySpark team. We have append, overwrite, ignore. So first thing that I'm doing is um, one second, why I have used these things. See. Okay, so in the output, right, in output 4, in which format? So I am not using any delimiter. So it is coming like this because the delimiter is dollar. So now if you use the delimiter as dollar, okay, so now it will show you the data properly, and we can also try to understand how many records it is really written into the output 4. See, one of the folder I have taken to show you, it has written a 1,25,773 records written into all the folders till now. Okay, so what happens, you have written in output 4 as a dollar. If you're not providing any delimiter, it will consider as a comma delimiter, as the comma is not the actual delimiter as per the data. So that's why everything will be treated as a single column. To avoid that, I have used a right delimiter, and I'm able to display the data to see the total records that we have written into one of the folder. I have tested. So yes, 1,25,773 as expected, all the records are written into these folders. Okay, clear? Now I am taking same df. Okay, I am using the same df, and if I append, how many records will be there, team? Now if I append, how many records will be there? Now tell me, 1,25,773 is there. Same df, I appended once again. How many records will be there now? Let's check. 2,51,000. 540. Okay, this is correct. Now let's say I'm taking a df and I'm overwriting into the same output 4. What will happen now? How many records will be there after overwriting?
1,25,000.
1,25,773 something. Okay, fine. Now very carefully understand and tell me, team. I am not using mode anywhere here, and you know that. Okay, let's say otherwise. Yeah, so in the output 4, you know something that we have the data in this output 4 or not?
Yes, we do.
We have in data in output 4 or not, team?
Yes,
We have
Malay,
data
we
in
have.
output. Now if I'm not using any mode, what will happen?
Should
Let's
throw
see.
error.
Nobody able to answer earlier. Now you can see it will throw error saying that this path already exists. Data is already available. So this is the error. This is called a mode error. Default mode is, if you're not mentioning, exist if error if already exist. Error if already exist means if the data in this folder, if at all any files or data is available, you have to throw error. That is the default mode. If you are not giving, that is what you will get error. Let's say I am giving 10 here. Sorry, output 10 I am giving, but I am not keeping any mode. Will it work or not? Yes, it will work, because error will be thrown only if some data exists, but output 10 is not having any data. I can able to
New false.
successfully write the data into output 10. Now first time I am able to write, second time onwards it is having the data. If you try to use the mode error if exists will immediately throw error saying that folder exists. Let's say in case if this target folder is having data, if I want to ignore the operation, I don't want to write it. So how you can do that? First, let me take the count of records in the output for to show you that. So 1,25,773. So I'm saying if data is already available, please ignore. Mode is ignore. I am saying. Now let's execute this. Now let's count it the number of records in this. How many records it is showing? Only 1,25,773, because this operation, instead of throwing error, if something is available, smoothly it will ignore. It will not execute the right operation. Okay, understood? Everybody's clear on this thing?
That's fine.
Yes. Yes.
Now let's talk about a write data frame to a custom CSV file. Now normally this is the data frame that we are trying to write it into the output 7 folder in the with the delimiters $. Okay. Now let's see how many part files, how many actual files that we have in this output 7, which is a fresh folder we have written. Now you see team, as you read the 2 files when you created a data frame, 2009 January, February files, 2 files you read. So 2 partitions it has created. Okay. And success, committed, started are the metadata files you have. Now what I wanted to do, by default what happens, so we will talk to like in depth of the partitions. Why only 2 partitions? So earlier session also, based on the number of cores, the parallelism is dependent on the number of cores. Even if you have a 12 partitions, if you have 8 cores, how many partitions will run parallelly? Now I'm repeating the question team. If I have a 8 cores, if I have a 12 partitions, how many partitions will run in parallel?
8 partitions.
People are saying 200 and only 8 will run in parallel, 4 will be picked in the next one. Okay, but this 12 is not recommended. I'll tell you why it is not recommended. Okay, I'll tell you why it is not recommended 12. Why it is not recommended is, let me confirm here itself. Okay, let's say you have a 8 people team, 8 people. You have 8 people who are working for construction of your house. Now you have a 12 tasks to be done. Okay, now what happens? First you have given a 8 tasks to the 8 people. The 8 people completed by afternoon. By afternoon they completed. Now from afternoon to evening 8 people are available. But how many tasks you have? But how many tasks you have, team?
4
How many
remaining.
tasks you have? Tell me.
Remaining
4.
4 we have.
How many tasks you have? 4 tasks. Is it an efficient way to schedule like this?
No.
What you have to do? You tell me. With this example, it is very easy example. You should tell me how many tasks I should create in this case.
8.
Either 8, if not 8, how many?
6 6.
6 6.
Or
I
4.
think 4
Okay.
will leave 8.
No. I think most of you confused. Let me tell you. Okay, let me clear this. Okay, I have some time today, so I'll talk about it. So I have a 12 tasks, but I have, see, 12 chocolates you can think of. I have 8
Mhm.
people. Now first you will give 8 chocolates to 8 people. Now these 8 people will eat the 8 chocolates. Next again 8 people are ready to eat the chocolates, but you have 4 chocolates only. Now what happens? When 4 people are eating chocolates, remaining 4 people are
Idle.
Nothing.
They're not
Yeah.
nothing.
Nothing.
so you are not meaning same 8 people only. First we have given 8 chocolates. All 8 people worked parallelly, completed eating 8 chocolates. Now same 8 people only ready now. Ready because eating first chocolate is completed for everybody. All 8 people are ready now. Now I am asking, if you have only 4 chocolates but you have 8 people, so in this case what happens? 4 people are working, remaining 4 people are idle. This is not a good practice. So to avoid this, chocolates, how you have to arrange it? Will you take a 8 chocolates? Will you take a 12 chocolates? Will you take a 16 chocolates? Will you take a 24 chocolates? Will you take a 32 chocolates? How you will take the chocolates? Chocolates is nothing but tasks. Think. Your brain also should think. I need to give time to think. I'm telling answers directly. No, you need to
We
think now.
take a
Tell me.
task into we take a task
With
into two.
tasks into two.
Uh, I mean, in even numbers we take.
Really, I am struggling a lot to explain to you. Yeah, see, simple, a simple answer. You people, nobody is able to guess it. Either you take 8 partitions, meaning you are instead of 12 chocolates, bring only 8 chocolates. Give it to the 8 people, it will be finished. No, you can't able to put them into the 8 chocolates. Make them as a 16 chocolates. Instead of making it as 12 chocolates, make them as 16 chocolates. Now what happens? First 8 chocolates will be eaten by 8 people. These 8 people, once they finished eating first 8, next 8 will be eaten by next 8 people again. Same 8 people will eat second chocolate. Now everybody will get a second task. Nobody is going to be idle. Now the third case is, here I am giving you chocolates. Let's imagine you have a cake team. Okay, you have 8 people. Now you can put the cake into the 8 pieces. Well and good. Now everybody will get one chocolates. Oh, sorry, one piece of cake. Good. You equally distributed. Now you have 8 people, but will you recommend to distribute the cake into 12 pieces or 16 pieces? Which one you will recommend? Now tell me.
16.
Which? Huh?
8, 8, 16.
Okay, good.
16.
8 is good. 8 is good. But let's say my data is very huge. I can't able to fit into the eight pieces. Then I need to divide this into the further. I need to divide this into the further. Let's say something like this. So I divided and somehow I got some 16 pieces. Let's imagine. Now first 8 you can give it to them, and next 8 pieces you can give it to the all the people. Now nobody is going to be idle. Let's say third case. So I have taken the cake pieces into 24. Okay, I have 8 people. Now what happened? First iteration you can give 8 pieces, next iteration you can give 8 pieces, next iteration you can give 8 pieces. 24 pieces will complete in parallel. All the people are going to work. Nobody is going to be idle. Understood? But now what
Mhm.
happens? Let's say if I have let's imagine scenario where I have a 16 course, meaning 16 people I have. Will you recommend creating a 16 tasks, meaning 16 tasks means 16 partitions will you recommend, or 24 partitions will you recommend, 30 partitions will you recommend, 32 partitions you will recommend, or 40 partitions will you recommend, or 48 partitions will you recommend? So which all partitions you will recommend out of all these numbers?
16.
48.
8.
48.
Okay, 48 is okay. Good answer. 48 is when you have huge data, you can go with 48. Otherwise, you can go with 32. If
Mhm.
the data is much more smaller, go with minimum 16.
Right.
Okay, your data is very small, I will go with only 2 partition. No, don't go, because 16 people are there. Why you need to give only task to 2 people, remaining 14 people? Why you want to keep them idle? Don't do that. Okay, so similarly here, 2 partitions read the data, like actually 2 partitions are created. Okay, so each partition, because we are reading 2 files, 2 partitions are created. How the partition number is decided, we will discuss tomorrow. So here 2 partitions are created with the part. So first partition written data into this, second partition is written the data into this. Now you can also know df only written, right? Df when we have written, it has written into the 2 part files. So now I want to know df is really having how many partitions, or did it not get num partitions? It is telling 2 partitions. That's why when I write the df, it is writing into the 2 part files. Okay, now what I will do, this is a new folder. This is the output 7 I have written here. Now I am writing into the output 8. But when I'm writing data into the output 8, I am writing with a single file. I'm writing with a single file, Koleskov 1. What it does, so it has written the data into the output 8 with a single part file. You can say single part file if you want. Okay, you can write it like this. Now what we want is from the output 8, from the output 8 is the our path. Okay, so this output 8, I want to list down whatever is there in this. See, in this output path, we have a success file. So we have first path, name, size, modification type. So now you can able to iterate through each of this file. So this is a list. In this list, from year to year, this is a one item. This is a second item. So meaning from each item, I can iterate. I can take. Let's say if I want names, I dot name. I can say. So only name of the file comes. Now I want a path instead of name. I want a path. So you can get a paths. If you want size of the data, so I want I dot name comma size. Each file size I want to know. See, name of the file is this 0 bytes. Name of the file is 113 bytes. Name of the file is 0 bytes. Name of the file is, it is around 22 million 678,360 22,678,360 bytes of data we are able to save it into this file. Now you know, understood it? I dot name means name, I dot size means size. Okay, I dot path means paths. You will get it from this. If you are not clear, you can see here above. So when you normally execute deb utils.fs.ls, in each of these you will have a path, name, size, modification type. So along with that, second path you will have, name you will have, size you will have. Fourth one, path you will have, okay, name you will have, size you will have. But what I really want out of all this, what I really want only I dot path. So that's why, so I want only I dot path. So that's why I'm taking only I dot path. So I have taken I dot path team. Yes. So now tell me, if I have taken this path, if I say underscore success in this text or not, true or false team, whether success is in this path or not, yes or no?
True. True. Yes.
Yes.
Yes, it's a true. Similarly, underscore committed, maybe you can give this these and all not committed, it's there or not there? Yes, true.
It's there.
Start, it's there or not? It's there, true. So like that, what I'll be doing, first I'll be executing I dot path, and I'll be taking the paths into a single list. So print list team here, I am just listing down. I'm taking the I, from the I I'm collecting the paths, and paths are saved into a one list. This is the second path, this is the third path, this is the fourth path. So now I am iterating through each of this path. I'm taking the one path. First I is nothing but a one path. Instead of I, you can say path. Okay, so that you will understand. So success in the path, success is there in this path, or committed is there in this path, or started is there in this path. You no need to give this started and not required. So if success, committed, started is there in this path, maybe it is recommended to give at least underscore at the starting, because if any file is coming with some same name, to avoid that confusion, underscore success, underscore committed, underscore started. If this is there in the paths, directly you take that path from. So if you have given this path, what happens if you use the rm command? It will remove. This is files, right? Files will be directly removed. If it is a folder, you need to give comma true to delete recursively delete files, then delete folder. But as we want to delete only file, directly we can say dbutils.fh.rm. In case if the file is not any of this, file is part. So because if nothing matched means the file is ultimately part file. You take that path. Here also you need to say path only. From that path you remove it. Take this part file path. Okay, this path you take and you move that file into the output 8 trip output.csv. Okay, now I am executing this and showing you. Currently you have all these paths. Now after running this, now if you check output 8, you will have only, see here, what is the file you have now? tripout.csv. The file we are able to rename it. This is how you can rename it. But this renaming you can do it, but it is not recommended to save the data into a single file unless you really need it. We are basically doing these things when we are exporting some data to the some downstream applications. We have very less data, so that's why we are able to do it, and we are able to rename it to one of the use case. But if you have such use cases, you can do, but it is not recommended on the large data sets. Okay, yeah, that's all today from my end, team. It's, please let me know if you have any questions. Any questions, team?
Come on.
Yeah, if no question, yes. Any questions? Okay, if no questions, then thank you.